Hello there. Welcome to all the students. We are here for the course selection for the subject regarding which is offered as an elective subject for the first year engineering. So we, on the behalf of the Mechatronics Engineering Department, we are offering the subject as fundamentals of Mechatronics Engineering. So my name is Professor A.P. Wosley from Mechatronics Engineering Department. The course offered from the as I said before, the course offered by the Mechatronics Engineering Department is Fundamentals of Mechatronics Engineering, and the course code for the same is SE187. So let us proceed with the basics of the mechatronics. Then we will see what are the course contents here, what are the course outcomes. We'll be seeing what is the structure of lecture and practicals, and finally the examination structures. So let us start with the basic mechatronics engineering. So you can see is that this term mechatronics engineering has been more popular in the last 2 decades or so. So we can see is that how we can predict how the mechatronics engineering has been derived from. So to make sure the mechatronics engineering department or mechatronics engineering is derived from two basic branches. First one is the mechanical engineering, and the second one is electronics engineering. So as the definition says, the word mechatronics is composed of mecha, M-E-C-H-A, from the mechanical department, and the T-R-N-I-C-S from the tronics department. So here we can say the mechatronics has been derived from the two basic branches. First one is the mechanical, and second one is the electronics department. So this term mechatronics was coined by Itusuro Mori, who was a senior Japanese engineer at Yasakawa Company in 1969. So it was quite a way back. So let us see what is the evolution of this mechatronics engineering, what are the advancements in the mechatronics engineering, along with the basics of the mechatronics engineering in these subjects. So we can say in earlier days, in initial days when this mechatronics term was coined, it was just inclusion of two branches. The first one is mechanical, and then the electronics. So as the time passed, staying in with the timeline, we can say the mechatronics is the synergetic integration of mechanical engineering, electronics engineering, and addition to these two basic branches, we can say it has included a control engineering and computer science engineering as the evolution of this department, or the evolution of this branch is done. So this mechatronics engineering, we can say is that it is the design of the computer controlled electromechanical system. So in the simple words, we have these basic two branches. First one is the mechatronics engineering. It's mechanical engineering, and the second one is the electronics engineering. And in addition to it, as the mechatronics branch has been evolved into, which has inclusion of this computer controlled, and we have also the computer science and control engineering. So in simple words, we can say it's simply a design of computer controlled electromechanical system. Or another definition, or another statement which we can quote for this mechatronic system or mechatronic engineering is that a mechatronic system is a computer controlled mechanical system. So we can say is that it is first of all it is based upon the two basic branches. First one is mechanical engineering, and the second one is we have the electronic engineering, and then we have the additional to it, that control engineering and a computer science engineering. So this can be well elaborated or well understood with the help of a graphics. So here we go, we have the graphics for this understanding of this mechatronic department, mechatronic engineering department. So at the periphery, we have the various applications where this mechatronic engineering is applicable, where the various fields we can say, or rather, where this mechatronic engineering is applicable, we can say. Then we have the basic branches at the inner circles, also the mechatronics. We have the basic branches such as computer, the mechanical, the electronic, and control system. So a conjunction of the two branches, maybe the computers and the control system, has been termed as the digital control system. Maybe the mechanical and computers, be the integration of this mechanical and computer system, can be represented as mechanical CAD, or some electronic system in integration with the mechanical system can also be given as the electromechanics. And likewise, we can also elaborate this, we can say the integration of this electronic system with the control system can be termed as the control electronics. So in the broader sense, if we see these mechatronics, we have now inclusion of these four branches: this mechanical, electronic, control system, and the computers. Any conjunction or any addition or any combination of these two branches has been represented as by their respective names. And at the periphery, we can say when this mechatronics engineering is applicable. So we can say is that it is applicable in case of automotive applications. For example, if you say in case of automotive applications, right from the basics of the power windows up to the advanced features such as the ADAS and or maybe the automatic parking systems in case of an automatic system or automotive system, sorry. So we have the application in the medical fields. So we can see the advanced operations where, for example, the knee operation of a person can be carried out with the help of the robots. So we have this mechatronics involved in it, which take care about the programming, maybe the operation of the that specific robots and robots for use for this manufacturing. Another classical example is the it can be used in the manufacturing use. So it is most widely used in this manufacturing use. It is just used for the automation of the manufacturing plants, the production system, and all. So as we see, we can, if we consider an assembly of an automobile industry or of a particular automobile, the assembly plant or the production line or maybe the assembly plant has various robots involved in it, which can be which work basically on this mechatronic system in this case. So this assembly or the manufacturing of any product, so specifically we can say is that in a particular automobile or a moped or something. So this automation of the manufacturing or assembly is made feasible. It's made easy with the help of these mechatronic systems. So we can say the basics here is where the mechatronic system is just we can say is it includes four branches: the mechanical, electronics, control system, and computers. And these are the various applications where these mechatronic systems can be used. Let's move forward. So we come here for the outputs of this course. So these outputs includes what the students might benefit, or what are the beneficiaries of this subject after learning this subject so we can say is that the first point is that students can understand various elements of mechatronic systems. So eventually, as we pass through the course or the content of the course, you will be coming to know what are the various basic elements of a mechatronic system. So in the broader sense, we can say the basic elements can be classified into maybe the sensors, actuators, the controllers, and the mechanical systems here in this case. And also the students will be able to understand not only the elements of mechatronic system, but also signal conditioning in this case. Then second, we have the demonstration of various sensors, actuators, controller algorithms for different applications. And lastly, the third output of this course is the students will be able to differentiate the PLCs, the microprocessors, and microcontrollers. In this case, what are the various PLCs are used in different applications? What is the classification of these PLCs? Maybe the use or the applications of microprocessors, and here in the case of microcontrollers too. So, in order to study this subject, the prerequisites for the subject are the students should be able to, the study should have the knowledge of the basic electronics to understand this course in this case. So let us move forward. This is the front page of your syllabus structure here. We have mentioned it earlier that the course code, the course learning outcomes in this case, the prerequisites also. Let us see what is in detail what is the course content of this subject. So first one is the introduction. As we can say, is the introduction includes the basic introduction. What is how this mechatronics term has been coined? What are the classical definitions of mechatronics? Who has coined this mechatronics, and what are the various applications for the mechatronics? Then we have the key elements of mechatronics, which is backed up by the block diagram of the mechatronic system. So what are the key elements, or we can say the principal components of the mechatronic systems are included or explained in the block diagram of the mechatronic systems, which stay basic. These are the basic or the fundamental blocks or elements, we can say, which can be observed in any application of mechatronics engineering. So these are the basic or fundamental applications, or basic or fundamental blocks, we can say. It can be used in various applications. Then we have the control system, a hand mode of controls. The most important here is the difference between the traditional and concurrent design process. So we have a broader differentiation between the traditional systems or the design process, and we just map them with the whatever the differences with the concurrent design process in this case. The second chapter includes the sensors and the transducers. Firstly, we go with the definitions of sensors and transducers. We can say there's a lot of confusion between how to differentiate between the sensor and transducers. I hope this will be clear in this topic, that the sensors and transducers, what objects or which objects needs to be classified as sensors, and which objects needs to be classified as transducers. Then we go with the classification of both the sensors and transducers. We are different types of the sensors and transducers in this case. And then finally we see what are different sensors, maybe the proximity sensors, maybe the light sensors, where they have been used, what is the operating principle in this every sensor, maybe the whatever the specifications, or for example the range and all, the compatibility with the another systems and all for the sensors. And finally we come to the conclusion or the differentiation between the sensors and the transducers. Then going to the third unit, we have the drivers and actuators in this case. So if you see, first of all, we just classify, we just have our definitions of these drivers and actuators. We make sure what if we are clear with the concept of the drivers and actuators in this case. What is the need of drivers and actuators that comes in the need and scope of the drivers and actuators? Then we have the classification of these drivers and actuators. So we have the hydraulic actuation system, maybe the linear, the single and double acting actuator system, the pneumatic actuator system in this case. And also we classify the drivers, maybe the electrical actuating system, or the stepper motors and servo motors used right from these small miniature objects towards large objects or large systems used in manufacturing engineering, or large objects used in various industries. Moving to the fourth unit, we have the unit which is dedicated to the PLCs, the microcontrollers, and the microprocessors. So, as being the most crucial or the apex point of mechatronics engineering, the PLCs, we concentrate more upon what is meant by a PLC. We give us more introduction about the PLCs. Then we have the block diagrams for various parts of the various components of the PLCs in this case. So we have the differentiation between these PLCs and relays used, because in earlier days the job of the PLCs was performed with the help of mechanical relays and all. So how this PLC is different from these relays, and what is the differentiation of this relays, or what is the operational constructional differences between these PLCs and relays in this case. So then we go for the microcontrollers and the microprocessors, the difference in between the microcontrollers and the microprocessors, what are different configurations of this microcontroller and microprocessors. We have been observing that there is a bit confusion between what a microcontroller and microprocessors are in the students, but I hope you will be more clear by attending this fourth unit and the differentiation between the microcontroller and the microprocessors. Moving on to fifth unit, the fifth unit includes the signal conditioning, the operational amplifier circuits. We have different basic operational amplifier circuits in this case, what is meant by filtering and what are the different filtering circuits in this case. Most important thing in this unit is the conversion or the process or the a system used for the conversion of analog to digital signals, or maybe the digital to analog signals. So, and now moving to the last unit, we have this advanced application in the mechatronics system. So it is now this unit is in touch with the whatever the we can say is that the most advanced features, or the whatever the we can say the advanced features, such as into a daily life, we can say maybe the automation in the manufacturing, maybe the use of artificial in the mechatronic system. We come with the different case studies, so and we can study how this mechatronic system is applied to this different case studies or different application zones in this case. So moving further, we can say is that the lectures and exam. So we have 2 lectures per week. So the total credits for the subject is 2. And here, if you see the structure of the exam, we have the in-semester exam for 20 marks. We have UT1, that is unit test 1, and unit test 2 for 15 marks. And finally, we have an end-semester exam of 50 marks. There is no practical exam or tutorial for this subject. So only we have 2 lectures per week, and the common exam structure, such as in semester 20 marks, UT1 we have 15 marks, and UT2 we have 15 marks, and in semester we have 50 marks in this case. So this was all about the fundamentals of mechatronics, the course content of mechatronics, the lecture and exam plan or structure, we can say in other words, is related to these fundamentals of mechatronics. So if you have any questions, you can directly contact. If you have any queries related to this subject or the content of this subject or the scope of this subject, you can contact me to me at Mechatronics Engineering Department. Thank you for giving me an opportunity for presenting this presentation. Thank you.